Before I observe any power cut, let's finish our, I think I should start my discussion. If you are facing any difficulty, let me know. I think we should start with a problem shared by the students. हा कोणी शेअर केला होता प्रॉब्लेम? आहेत का ते स्टुडंट्स? Am I audible, students? Am I audible?
Yes, sir.
Yes, sir.
हा प्रॉब्लेम ज्यांनी शेअर केलेला तो आहेत का? विद्यार्थी आहेत का ते? Okay. See, in the yesterday discussion, we had an ordinary differential equation. Today, we'll focus on partial differential equation, how to find the solution. Now, basically, in a partial differential equation, we learn there are three techniques. One is called as a Laplace equation, second is the Poisson's equation, third is the parabolic equation. In examination, generally, they will not mention like a Laplace equation. Here it is mentioned, right? You can see that it is mentioned a Laplace equation. Can you follow the cursor? Is it visible to all of you? I think now it's visible, right? Oh. So let us try to understand what's this problem statement. And specifically, the students have shared it from last year examination, if I'm not wrong. So given values, u is a function of x and y. U is a function of x and y on the boundaries of a square is as follows. Evaluate the function uxy, satisfying the Laplace equation. Now, most of the time, students, Laplace equation may not be mentioned like this word, what I'm saying, but they will provide you this equation. That equation itself is the Laplace equation, right? You can see that explicit elliptic solution, Laplace equation, can be represented like del square u upon del x square plus del square u upon del y square is equal to 0, which can be also represented in another way. So this is all the Laplace notation. We are talking about C. The equation can be represented like del square u upon del x square, del square u upon del y square. The Laplace and the Poissons are generally used where the time function is absent. We don't have a time function. So it's a function of x direction and the y direction, right? So this is a Laplace function. If del square u upon del x square plus del square u upon del y square, if it is equal to 0, then it's called as the Laplace equation. Otherwise, del square u upon del x square plus del square u upon del y square, if it is equal to function of f xy, then this is called as Poisson's equation. The notations, you can find out different notation in examination, maybe in questions. We can represent this term as uxx square and this term as uyy square is equal to 0. This is again known as Laplace equation. The same can be represented like del square u is equal to 0. So where del square is nothing but del square upon del x square plus del square upon del y square. So this is what the interpretation. And if I'm adding u, that means that you are taking second order differentiation of u, which is the function xy, right? You can stop me anywhere if you are not able to understand, then you can stop me. Let us come to the question. Hope you understood the difference between, and whenever the function is a function of time, you have to use a parabolic. Here you can see that it's not a function of time, it's only function of direction, right? But with the time present in the problem statement, that means what you have to use parabolic equation. That is what we learn in theory class, right? So let's try to solve this numerical. In this numerical, what is given? Solution. In a solution, let us write what is given. Can you help me out to find out what's given in the problem statement? The first is the Laplace equations. Okay? So Laplace equation is given, and that Laplace equation is being represented del square u is equal to 0. Sometimes this segment or the words are not given, so directly equation is given. That you have to understand. This is the Laplace equation. Then the boundary conditions are given for the top 1000, for the bottom 500, for the left 2000, and right 500, and the grid system that we are having 3 by 3. Okay, so that is what the information we have. So let us prepare a grid. It has an x-axis and the y-axis. In this x and y-axis, we have to place a square because it's a square, no? A square as a follow. So it is going to be a square. Now square is 3 by 3. Means what? Lower left corner, it is 0, 0. And upper right corner, it is 3 by 3. So this is what the grid system. Now it is a 3 by 3 grid point. So we have to divide this entire x-axis and the y-axis with a step size 1. So I will divide this like this is going to be 1, and this is second. And here also we will have equal step size on y-axis. So this is your grid. Okay. Now in this grid, we will write this point. This point is nothing but let's say that u1, this is u2, this is u3, and this one is u4, right? And the grid distance or distance between grid point is 1 along x-axis, along y-axis it is 1. Even though it is not mentioned, but this is a 3 by 3 grid point, so you can find out the grid points here. Okay. Now we have to find out the value of u1, u2, u3, u4. Right? But for that, what additional information we have? You can see that the top layer, it is subjected to the 1000. Bottom is subjected to the 500. Left is subjected to 2000. And the right is subjected to the 500. So we got all this grid system. And for this grid system, now we have to find out a solution. Finding the solution using a Laplace equation does mean you have to find out u1, u2, u3, u4. So let us find that. Okay. So how to find this? First of all, we should know the equation for u. What's the equation for u? Can you tell me, students? Anyone? What's the equation for u? Let us say that this is the u point that we have to find out. This is u right, this is u up, this is u down, and this is u left. Can you tell me the formula for u? Please, first.
Yes, sir.
Yeah, 1 upon 4
4
in bracket
into in bracket ur plus
u
u left, u up plus u down.
U up plus u down. So you have to take a simple summation of all these terminals. Okay. So what is this basically? So let us try to understand what is this and how we can use this formula to find the value of u1, u2, u3, u4. This all these things we have discussed in theory class, but again as a part of revision. So 1 for u1. We are going to find out u1, this value. So for the students, the center value is u1, right? This u is nothing but the center value. This is nothing but the center value. So u1 is the center value. For u1, I can write or I can prepare a diagram plus sign. Okay. So where u1 will be a center value that we have to find out, right? So for the u1, what is the right value? Please, students, for u1, I'll consider this grid, no?
u2.
Plus sign.
u2.
Try to understand. This is what I'm considering. Okay. So here it is u2. Here u4. On this side it is
2000.
And bottom it is 500. So once we are having this, can we write u1 is equal to 1 by 4 constant 1 by 4 U2 plus U4 plus 2000 plus 500. Let us simplify this equation. 4U1 U2 plus U4 plus 2000 plus 500. Okay. Rewrite this equation for U1. Let us say that 4U1 minus U2 plus U4. Oh, it should be minus, sorry. It is U2 minus U4 minus 2000 minus 500 is equal to 0. So that is your equation number 1. Okay, from U1. Any difficulty, any questions, students, by the time?
No, sir.
Now, we will write for U2. For U2. For U2. So we will prepare a grid again for U2. So this is U2. Now, from this, can you tell me what's top, up value, right value, left value, and bottom value? U3, U1, 500, 500, right? So let us write these values. It is U3, 500. So 500. And what's this value?
U1.
U1, right? Correct. Now let us write for U2. So U2 is equal to 1 by 4. And you have to take a summation of all these terminals. That's so simple. U1, U3 plus 500 plus 500. Right? Rearrange this equation and write in the form of this. 4U2 is equal to U1 plus U3 plus 500 plus 500. Right? So we'll write minus U1 plus 4U2 minus U3 minus, okay, 500, 1000. You can write. That is the equation is equal to 0. That's the equation number 2. And here also we can write now 4U1 minus U2 minus U4 minus 2500. So I'll write this as an equation 1. Okay. Now similarly, we are going to write for U3. So third, for U3, prepare a plus sign considering U3 as a center value. So that is going to be U3. So for U3, here it is a 500. Correct me, students, if I'm going if I'm writing some wrong values here. 1000. On right, it is U4. Right? Bottom, U2. Right? So let's write for U3. U3 is equal to 1 by 4. U2 plus U4 plus 1000 plus 500. So 4U3 is equal to U2 plus U4 plus 1500. Now simplifying this equation, like U2 minus U2, I'm taking all these terms on the other side, plus 4U3 minus U4 minus 1500 is equal to 0. So this is equation number 3. Similarly, we are writing the equation for U4. The fourth is for U4. So for U4, so U4 is the center value, and for this U4, it's a 1000. Here it is 2000, U3, and U1, right? So let us write for U4. U4 is equal to 1 by 4, U1 plus u3 plus 1000 plus 2000. Right? Simplifying. 4u4 is equal to u1 plus u3 plus 3000. So let's write minus u1 minus u3 plus 4u4 minus, we will keep this constant on the other side. That will be better. We will keep this as an example here also. Okay, I'll modify this equation. That will be better because we have to write a simultaneous equation, right? 4u3 minus u4 is equal to 1500. So let's say that this is equation number 3. And this is equation number 4. Similarly, I'll modify or rewrite, not modify, rewriting this. u1 plus 4u2 minus u3 is equal to 1000. That is equation 2. Just erase it. And similarly, we'll write this also. For u1 minus u2 minus u4 is equal to 2500. We got all these equations, 4 equations. Any doubt, students, to get the 4 equations? Yes, students? Any question? I'll collect all these 4 equations. I'll try to write for u1, u2, u3, u4. Okay, these are the 4 equations. So let us write. Let's write 4 simultaneous equations. Help me out to write the simultaneous equations, students. 4u1 minus u2 plus 0u3, because u3 is not present, minus u4 is equal to, can I write in this way? Because I want all these terms. Hello, students.
Yes,
Hello?
sir. Yes, sir.
Yeah. Tell me second equation.
minus
second
u1
Minus u1
minus
plus 4u2
4u2
minus u3
minus u3.
plus 0u4
Correct.
is equal to 1000.
Good. Next. Next. For u3, we got an equation.
0u1
0u1
minus u2
minus u2
plus 4u3
u4 is equal to 1500. Correct. The last equation is now visible to all of us. We'll write minus u1 minus, plus 0u2 minus u3 plus 4u4 is equal to 3000. Okay. These are the 4 simultaneous equations. Now, hereafter, the unknowns are u1, u2, u3, u4. So we are having 4 unknowns, right? And 4 equations. Okay. Either you can use Gauss elimination to solve this equation, or you can use Gauss. Any of this method you can use. Okay. So 4 by 4, you have to solve by using Gauss elimination or Gauss error. But if you are using the Gauss elimination, this is my personal opinion. You can use Gauss elimination. Some books, they are using Gauss elimination with partial pivot. My recommendation is to go for Gauss error. It's a very easy method. You can find out. And see, students, the question which is asked for the examination is of 10 marks. So 10 marks does means, see, this is very simple. To get the equation is very simple part. So you will get the half of the mark to get the simultaneous equation, right? There should not be any challenge to write this equation using Poisson Laplace, right? But the challenge is to get the value of u1, u2, u3, u4. And here, the remaining marks are allotted for Gauss-Seidel or Gauss elimination. So that also marks will be there for the steps. And few marks will be for representing your final answers. Right? So here I'm using Gauss-Seidel. Let us use Gauss-Seidel. Gauss-Seidel. It's a kind of revision for the Gauss-Seidel as well, students. Those who are attending this first time. In a Gauss-Seidel, first of all, these equations, what's the first step in a Gauss-Seidel, students? Can you tell me anyone? We got on 4 equations or 3 equations? 3 unknown.
Pivot
Yes,
elements.
come. Yeah, you have to first check that the diagonal elements are maximum. And fortunately, for Poisson's Laplace, we always get diagonal element as a maximum. Right? So Gauss-Seidel says that you have to check this condition all the time. Summation of all diagonal elements must be greater than equal to summation of remaining elements. Right? Mode of. So this is the condition. If this condition is being satisfied by the set of equation, then we can apply the Gauss-Seidel. If not, then you have to switch the equations. Okay, ensuring that this condition will get satisfied. In other words, it is not always in the theory class practical sections also I told you, it is not always mandatory to have a maximum values along the diagonal. In some cases, you have to compromise the maximum value, but ensure that this condition is satisfied. Okay. So now in this case, equation 1, 2, 3, 4, the diagonal elements are maximum as compared to the others, right? So it is already in maxima diagonal. So what I'm doing, using equation, let us say that A, equation B, equation C, equation D. So I'll write from equation A. So what I'll write for Gauss-Seidel, no? I'll write for U1 because I'll consider this as a maximum element. I'll write U1 is equal to now 1 by 4. I have to write an equation for U1, 1 by 4. 2500 plus U2 plus U4. Any question? Any doubt? Any questions, students? Hello?
No, sir.
Okay. Now, similarly, we can write from B. We will write now for U2. U2 is equal to 1 by 4, 1000 plus U1 plus U3. From C, we can write for U3. U3 is equal to 1 by 4 in bracket 1500 plus U2 plus U4. And from B, we will write for U4. U4 is equal to 1 by 4, 3000 plus U1 plus U3. So we got all these equations. Now we have to apply the Gauss-Seidel. How to apply this Gauss-Seidel? Tell me, students. Now we got all these 4 equations. We have to apply Gauss-Seidel. Tell me. Hello. I request all of you students, please respond. It's a revision. I'm not teaching you right now. It's a revision. You have to tell me. Otherwise, tomorrow is the examination. Still, you are not able to understand or you are not able to answer the question like what's the consider? What's the next step?
So put the equation in calci.
Yeah, first is you have to write, put your equation in calci. But before that, okay, you have to do all these things. But while doing that in a calci, I'll consider this as u1 as a because I need 4 parameters. No. So what variables we have in calci? A, B, C, D. We got an A, B, C, D, right? So can I write here U, use different color. U1 is A, right? U1 is A, U2 is B, U3 is C, and U4 is D. Can I use this one?
Yes, sir.
Now I will have a modification like U1 is A, here U2 is B, and U4 is D. Okay, D. Then here U3 is C, here U2 is B, and U4 is D. Here you can see that U1 is A and U3 is C. U1 is A, U3 is C. So you can write these equations. Any questions, friends? Any questions? Hello.
सर पण कॅल्शियम टाकले की ते व्हेरिएबल एरर येते.
काय तर
व्हेरिएबल एरर.
एकच मिनिट. सो ही कॅल्शियम मध्ये काय? ओके, मी तुम्हाला सांगतो कसं करायचं कॅल्शियम. So I have to write that equation in the calcium. See, students. You have to write an equation for U1. U1 is what? 1/4. So I'll write here. Is it visible? Calcium is visible to all of you?
Yes, sir.
2500 plus U2 is what? Alpha B, right? Plus alpha D over 4. So this is the equation for U1. Is there any problem? Then you have to say cal and substitute the value of B, D, and you'll get the answer. Is that okay? Similarly,
Yes, sir.
now that will be in a memory now, students. I can recall that equation like this. If I'm writing in second equation for U2, I will write like this. 1000. So calci, use of calci is very important. You should know. Alpha A. And this is the trick we are using. And that makes the solution very simple. Right? So less time. Then calc. You can put in value of A, C, and you'll get the answer. And still, both the equations are in memory. You can see that. This is for AC means what? This equation. And earlier equation BD, that is also in a calculator. So similarly, you can write for U3 and U4. All 4 equations are in a calci, in memory. You can easily access them by navigating, and accordingly you can do the calculation. Any question now? So
No, sir.
next what we are going to do, we are assuming, come on, assuming, or we'll say that let, not assuming, let U1 is equal to 0, U2 is equal to 0, U3 is equal to 0, and U4 is equal to 0. So what are these in our notations? A, B, C, and D. Right? So after this assumption, now we are going to prepare a table. Now I'm not going to explain you the entire calculations. but few calculation together will have a calculation C students U1, U2, U3. Okay, and the accuracy you can consider here, accuracy 0.01. If it is not mentioned, you have to consider this. So for an accuracy, you just keep on checking accuracy. This is for U1, this is for U2, and this is for U3. And let us write values. So this is iteration numbers. Obviously, the first iteration is 0, 0, 0 because we are solving for U1, U2, U3, U4. So that is your iteration number 1. But since we are using Gauss seidel as a secondary method to find the variables, so I'm not writing the iteration 1 and 2. अगर यही क्वेश्चन आपको एग्जाम में पूछा है, solve the following simultaneous equation using Gauss seidel, then you have to show the first 2 iterations calculations and remaining calculations you have to show in table. This is mandatory. Okay. U1, U2, U3, U4. Then here you're supposed to write U1 old minus U1 new mod. Similarly, U2 old minus U new, U2 new. Similarly, you can write mod of U3 old minus U3 new. And the last one is mod of U4. And you just continue. Okay. So you can write here. Now we have to find out U1. So for us, U1 is what? A, U2 is B, U3 is C, and U4 is D. Now I have to find out U1. So use on calculator. So what's the equation for U1? ये equation है ना U1 के लिए. Hello students.
Yes, sir.
हाँ, so पहले जो assumptions value है 0, 0, 0. All values are 0, 0. So I'm going to put that. What's the value of B? 0.
0.
What's the value of D? 0.
0.
So what's the value we are getting here?
6 to 5.
6 to 5. Okay. Now, जब भी हमें न्यू वैल्यू मिल गई तो पुरानी वैल्यू को क्या करेंगे हम लोग? स्क्रैच करेंगे. ठीक है. नेक्स्ट कौन सा इक्वेशन है? नेक्स्ट कौन सा है? U2. U2 का यही फॉर्मूला है हमने जो सेव किया था. सो U2 का फॉर्मूला में क्या चाहिए? U1, U3. अभी बताओ कौन सा U1 लेंगे हम लोग यहाँ पे?
0 ना सर.
न्यू वाला.
मैंने 0 कट कर दिया ना U1 का वैल्यू.
Okay,
We
sir.
are not going to use that once I get the new value. है ना? ये कट कर लिया ना मैंने, देखा है आपने? इसको कट कर लिया मैंने. Can you see that? बघितलं का
Yes,
कट के
sir.
लिया. भाई U1
Yes,
वैल्यू अवेलेबल नहीं है. You have to use a new value. Right? 6 to 5 and next C. C ची value म्हणजे U3 ची value 0. So what you are getting? 406. 406.5. जब मुझे नया वैल्यू मिल गया तो I had to strike the old one. Similarly, can you find out U3? U3 के लिए now I have to write a formula. बताओ क्या है? 1500 प्लस U2 मतलब अल्फा B प्लस U4 मतलब अल्फा D. इक्वेशन एक बार चेक करो करेक्ट है. अगर इक्वेशन गड़बड़ हो गई यहाँ पे लिखते वक्त तो पूरा सोल्यूशन इवन दो यू नो द मेथड्स पूरा गलत हो जाएगा. सो कैलकुलेट. नाउ लेट अस कैलकुलेट दिस. U3. What should be the b value now? क्या रहेगी?
406.25.
Yes, 406.5. और नेक्स्ट क्या चाहिए? डी की वैल्यू. डी की वैल्यू क्या रहेगी यहाँ पे?
0.
0. अभी ये आंसर आ गया. क्या आएगी? 476. 476.625. 625. ये नई वैल्यू मिलने के बाद पुरानी वैल्यू क्या करेंगे? हम स्ट्राइक करेंगे. सिमिलरली द नेक्स्ट वन. बताओ नेक्स्ट वैल्यू क्या रहेगी? इक्वेशन 3000 प्लस U1. U1 मतलब A एंड C. अल्फा A प्लस अल्फा C divided by 4. Calculate. What's the A value? 625. And what's the C value? 476.625. ठीक है, देखो निकालो इसको अभी. 1025.4062. 4063 ना. ये नई वैल्यू मिल गई, पुरानी को स्ट्राइक करेंगे. सेकेंड वैल्यू. नाउ जस्ट टेल मी नाउ स्टूडेंट्स, अभी मेरे पास सभी इक्वेशंस है यहाँ पे. बताओ आई कैन गेट दैट इक्वेशन. फिर से हमें टाइप नहीं करनी है वहां पे. कौन सा इक्वेशन? ये ही ना, U1 के लिए. फिर से ना इक्वेशन U1 का.
Yes, sir. Yes.
कॅल्क्युलेट. आता बी व्हॅल्यू सांगा मला. बी व्हॅल्यू काय असेल?
406.5.
405. ओके. डी व्हॅल्यू काय असणार आहे?
1025.
025.4.
4063. 982.9766. 982.9766. अभी ये नई वैल्यू मिल गई, पुरानी वैल्यू को क्या करेंगे हम लोग? स्ट्राइक करेंगे.
Right.
चलो अभी कौन सा है? U2 निकालना है. U2 का कौन सा इक्वेशन है बताओ? ये U2 है 1000. कैलकुलेट. ये वैल्यू क्या है बताओ? अभी ए की वैल्यू क्या रहेगी?
982.9766.
9766. सी की वैल्यू 476.625. हाँ 614.900614. ये 614.900. ये नई वैल्यू मिलने के बाद पुरानी वैल्यू क्या करेंगे हम लोग? स्ट्राइक करेंगे. एक लाइन पेंसिल से एक लाइन मारना है. पूरा ऐसा दिखना चाहिए वो वैल्यू एग्जाम. ये हमारा मेथड है स्टूडेंट्स. वी आर यूजिंग दिस मेथड, है ना, टू मिनिमाइज द एरर्स. चलो अभी ऐसे ही सॉल्व करते जाओ. कब तक सॉल्व करना है? ये वैल्यू जो है ना, अनलेस एंड अंटिल यू आर गेटिंग दिस 2 डेसिमल्स रिपीटिंग. एक भी अगर रिपीट हो रहा है ना, ये भी, you can stop number of iterations. कब तक करना है ये? Until you are getting this value repeating. For example, एक last value आ रही है. Let us assume that maybe 625.03, है ना. तो हम लोग को नेक्स्ट वैल्यू क्या आएगी 8 इटरेशन को? फॉर एग्जाम्पल यही नहीं आने वाली है. सो यू कैन से दैट 06. 9 में क्या आएगी? 625.08. है ना। अभी देखो ये वैल्यूज है रिपीट हो रही है डेसिमल की, ये तो हो रही है, दैट मीन्स व्हाट, द वैल्यूज इज क्लोजर टू द फाइनल आंसर, सो यू कैन राइट योर आंसर, लाइक यू स्टॉप इटरेशन फॉर दिस, जस्ट कंटिन्यू, अगेन यू हैव टू कंटिन्यू, जब तक वैल्यू रिपीट नहीं हो रही है यू हैव टू कंटिन्यू. When you are using Gauss seidel as a secondary method, जेव्हा तुम्ही गॉस सिडल आहे ना सेकंडरी मेथड यूज करता आहात, जिथं कुठलीही कंडिशन दिलेली नाहीये, टर्मिनेशन, किती आयटरेशन सॉल्व्ह करायचे आहेत, काय एरर आहे हे दिलेलं नाहीये, त्या ठिकाणी यू कॅन अप्लाय दिस रूल ऑफ थंब रूल, जिथं जिथं तुमचे व्हॅल्यूज रिपीट व्हायला लागतील तिथं तुम्ही ते इटरेशन थांबवतील. हे एकच झालं, असंच ह्याचं पण रिपीट व्हायला पाहिजे, ह्याची पण रिपीट व्हायला पाहिजे, ह्याची पण रिपीट व्हायला पाहिजे, आणि ज्या मोमेंटला तुमच्या व्हॅल्यूज रिपीट होतील त्या मोमेंटला तुम्ही थांबणं गरजेचं. हे क्लिअर आहेत गोष्टी? हॅलो स्टुडंट्स, लक्षात आलं गॉस सिडल?
Yes, sir.
सो दिस इज व्हेरी सिम्पल, 10 मार्क डन. मॅक्सिमम वेळ आपला हाच ह्याच्यासाठी जातो सोल्युशन, बाकी मेथड सोपी. पॉइजन सांगायची गरज आहे, फक्त आपल्याला इथे झिरोच्या ऐवजी फंक्शन आहे. काय इक्वेशन असेल पॉइजन्स मध्ये? सांगा, यूचं इक्वेशन सांगा. यूचं इक्वेशन पटकन सांगा. U is equal to 1/4
4 into u right plus u left plus u up plus u down minus h into f of x.
नाही, काही ते गडबड होते का?
एच स्क्वेअर एफ ऑफ एक्स
Square, H square
H square
स्क्वेअर
f
एक्स
into
स्क्वेअर,
F of X.
हा एफ ऑफ एक्स. आता हे एफ ऑफ एक्स वाय कुठून काढणार तुम्ही? ग्रिड.
गिवन
Coordinate.
इक्वेशन.
हा नाही नाही नाही, ग्रिड सिस्टम तुम्हाला पुन्हा फॉर्म करावं लागेल,
Coordinate.
है ना. त्याच्यात ग्रिड लेन दिलेली आहे 1 1, आणि तुम्हाला ह्या व्हॅल्यूज फाइंड करायचे, आणि सगळ्या यूच्या व्हॅल्यूज आहेत ना बाउंड्रीजला 0 आहे. तर तुम्हाला काय करायचं, U1 U2 U3 आणि U4 काढायचे. मग काय करायचं, हे ग्रिड सिस्टम कुठल्या कोऑर्डिनेट सिस्टम मध्ये आहे, लोअर लेफ्ट कुठे आहे बघायचं. जर दिलेलं नसेल, मेन्शन नाही केलेलं असेल, बघ एक्स वाय म्हणजे साईज बघा किती आहे, एक्स वाय 0 0 आहे आणि एक्स वाय 3 आहे, म्हणजे इथे 0 0 आहे आणि इथे किती आहे 3 3, म्हणजे ओरिजिन कुठे आहे इथे. सो ओरिजिन तुम्हाला माहित झाला तर याचे तुमचे कोऑर्डिनेट्स काढू शकता. सांगा U1 चे कोऑर्डिनेट्स काय आहेत?
1 1.
U2
2 1.
U3
2 2.
2 2
आणि U4
1
1
2.
2.
1 2
Yes
1
sir.
2 or 2 1?
1 2. X Y.
I made a mistake somewhere. It is U4. हा, it's a 1 2. म्हणजेच काय की U1 1 1 आहे. 1 वर आता काय होतो, एक्स अँड वाय ची व्हॅल्यूज तुम्हाला दिलेले आहेत. एक्स इज इक्वल टू 1, वाय इज इक्वल टू 1. आणि हे जर तुम्हाला माहिती असेल तर यू हॅव टू सबस्टिट्यूट इन द फंक्शन. फंक्शन काय असणार आहे इथे सांगा स्टुडंट्स? इक्वेशन काय दिले?
Minus 10.
डेल स्क्वेअर यू इज इक्वल टू -10 एक्स स्क्वेअर प्लस वाय स्क्वेअर प्लस 10 आहे. ठीक आहे, मग याला मी कम्पेअर केलं स्टँडर्ड फॉर्मशी. स्टँडर्ड फॉर्म मी लिहू का, डेल स्क्वेअर यू अपॉन डेल एक्स स्क्वेअर प्लस डेल स्क्वेअर यू अपॉन डेल वाय स्क्वेअर इज इक्वल टू एफ ऑफ एक्स वाय. म्हणजेच काय, विल गेट दी एफ ऑफ एक्स वाय इज इक्वल टू -10 एक्स स्क्वेअर प्लस वाय स्क्वेअर प्लस 10. आता ही काय असणार आहे, U1 फाइंड करताना काय असेल इक्वेशन आपलं, कसं लिहाली U1 साठी? परत ग्रिड सिस्टम लिहायची U1 साठी. U1, tell me here what is this? U2, U4, and this is 0, and this is 0.
0 0.
So I can get the U1 is equal to 1/4 U2 plus U4 minus H ची व्हॅल्यू काय दिली इथे? h ची व्हॅल्यू काय?
1.
1.
म्हणजेच काय इथे 1 चा स्क्वेअर इंटू नाव दिस इज फंक्शन ना, हे फंक्शन आहे. फंक्शन कशासाठी लिहितोय आपण? कशासाठी लिहितोय?
U1 साठी.
U1.
U1 साठी लिहित असेल तर फॉर U1 x ची व्हॅल्यू काय?
is 1.
1.
X ची 1 आहे, Y ची 1.
y ची 1 आहे. मग ती कुठे सबस्टिट्यूट कराल?
F of XY.
फंक्शन मध्ये.
जी काही व्हॅल्यू येईल ना फंक्शन एफ ऑफ एक्स वाय ती इथे लिहायची. काय ते व्हॅल्यू बघा बरं. परत हे इक्वेशन तुम्हाला लिहायचं आहे कॅल्सियम मध्ये.
150.
150 correct, and get the value of u1. So again you will get the equation here, 4u1 u2 plus u4 minus 150. बरोबर आहे ना? मायनस 150
Yes,
येते
sir.
ना? तर काही गडबड होते?
Plus 150 sir.
नाही, इथे काहीतरी व्हॅल्यूज काही गडबड आहे, चुकते काहीतरी. ही व्हॅल्यू किती आली?
त्याची -150 आली सर.
हा, मायनस 150 आली इथे. मग की मायनस मायनस प्लस झाले. मग यू कॅन राईट दिस इक्वेशन लाईक 4u1 minus u2 minus u4 is equal to 150. This is equation number 1. आता लाप्लास आणि पॉइजन्स मध्ये एवढाच फक्त डिफरन्स आहे फंक्शन. u2 साठी सांगा मला एकदा, म्हणजे आय विल क्लोज दिस डिस्कशन. So let us write for u2. Tell me students, u2 इथे काय? 0
0.
u3. हा, u2 साठी
So
u2
0 0.
इथे u3 आहे ना?
Oh. Yes sir.
Is it u3?
U3.
u3 u1
U.
u1 and this is 0,
0.
0.
right? This is u2 is equal to 1 by 4, u3 u1 plus u3 minus h square 1 square into.
Function.
आता इथे for u2 what is x value for u2? x काय u2 साठी?
2.
2.
2.
2 आणि y काय?
1.
2. 1.
x is equal to 2 and y is equal to 1. हे आता पुढे सबस्टिट्यूट
One.
कराल. पुढे सबस्टिट्यूट कराल इक्वेशन मध्ये. या इक्वेशन मध्ये सबस्टिट्यूट करा. या वाले सिंपल आहे ना? एवढाच एक डिफरन्स आहे. सांगा ही व्हॅल्यू किती येते?
सर इथे -150 होती, आधी वरच्या ह्याच्यात -120 यायला पाहिजे.
यस सर, -120 आला पाहिजे वरती.
इथे 120 यायला पाहिजे का?
हा, आणि खाली 150 येईल सर.
Okay.
-150.
हा, so take care of this. -120. So here you will get +120. 120. Here it is -150 ना?
येस सर.
बरोबर आहे ना?
Sir.
Okay. We will rewrite this equation. This is very important, students. Carefully handle this situation. Then 4u2 is equal to u1 plus u3 plus 150. So I can write here minus u1 plus 4u2 minus u3 is equal to 150. So that is equation number 2. Similarly, you will get u3, u4. And हे सगळे इक्वेशन आल्यानंतर again to find out value of u1, u2, u3, use Gauss seidel. Use Gauss seidel. So Gauss seidel is very, very important. Very, very important. आणि जी मेथड आपण क्लासमध्ये शिकलोय किंवा आता शिकलेलो आहे तीच मेथड गॉस सेडलची वापरायची. ठीक आहे. पॅराबोलिक, शुड आय एक्सप्लेन पॅराबोलिक? करायचे का डिस्कस पॅराबोलिक साठी?
Yes sir.
येस सर.
यस सर.
येस. पॅराबोलिक झालं की एकदम, आता गॉस सेडल तर मी सांगितलंय तुम्हाला. थॉमस अल्गोरिदम एकदा सांगून देतो. Tridiagonal matrix.
Gauss elimination also.
गॉस एलिमिनेशन. गॉस एलिमिनेशनचं बेटा सोल्युशन मी दिलेलं आहे तुम्हाला. तुम्ही एकदा चेक करा गुगल क्लासरूमवर. तरी पण मी गॉस एलिमिनेशन सांगून देतो. ठीक आहे. म्हणजे आपले आता 2च पार्ट राहतात आणि फ्लोचार्ट मात्र सगळ्यांचे करा. तुमच्या पुस्तकात मी बघितलं जस्ट की एक्सप्लेनेशन पण दिलेलं आहे फ्लोचार्टचं. है ना. इव्हन प्रोग्राम सुद्धा अवेलेबल आहेत काही पुस्तकात.
येस सर.
हा, तर ते काही जास्त डिफिकल्ट नसायला पाहिजेत. मी तुम्हाला पहिल्या युनिटमध्ये सांगितलेलं हाऊ टू प्रिपेअर अ फ्लो चार्ट फ्रॉम अल्गोरिदम. सो ते मेथड्स तुम्ही फॉलो करून यू शुड लर्न हाऊ टू राईट अ फ्लो चार्ट. ओके. सो लेट्स डिस्कस दिस पार्ट. Then Thomas algorithm. Thomas algorithm is again very simple. Just follow it, and then we'll discuss about Gauss. Should I repeat Gauss-Seidel again?
No, sir, no.
Okay. So this is very simple. NR method. NR method is again very, very important. Very important. Prepare this and use the class method only. First of all, you have to check the convergence, condition of convergence, right? And then you have to proceed to find out x2 value. Okay. See what's given in this problem. Solution. Okay. Am I audible, students?
येस सर.
Yeah. Let us discuss this question. Now it is not mentioned which method you have to use, right? Whether Laplace, Poisson's, or parabolic. Can you tell me how do you identify the methods which we have to apply here? Poisson's, Laplace, or parabolic?
Sir, when the relation between time and x is given, we use
Yeah. When
Laplace.
time function is present, when time function is present, what is when time function is present, no, then you have to use parabolic, right? So let us read this question carefully and tell me what's available in this problem statement and how to proceed. It's a very important students. If you understood what's the problem, 50% part is done. Initial temperature at T is equal to 0. Initial temperature at T is equal to 0 within an insulated cylinder of 4 centimeter length is given by this equation. So what is given in the problem statement? One rod which is placed on x-axis is a cylindrical rod which is placed on x-axis, right? And the length of this rod is 4 centimeter. Okay. When time is equal to 0 at time is equal to 0, the temperature is being governed by the equation T is equal to 15, 4 minus x for a length 0 to 4. So I can say that x is equal to 0 and here x is equal to 4. Is that clear?
Yes, sir.
Hello? Yeah. And distance is given in the centimeter. Right. Both ends are maintained at 0 degrees Celsius. What does it mean? At x is equal to 0,
Temperature is
temperature
0,
0 degrees Celsius. And when x is equal to 4, temperature is
0 degrees Celsius.
0 degrees Celsius. Okay. Find the temperature as a function of x for time which varies from 0 to 1.5. Time is varying from 0 to. So we got an additional information from this. What is that? X varies from 0 to 4 centimeter and time varies from 0 to 1.5. Any question? If the heat flow is governed by this equation, tell me, students, what else we are having here?
Sir, values of H and T.
Now, just tell me this value, meaning of this one. The heat flow is governed by means what? The equation is given. What's that equation? Is that the equation which governs the heat flow?
Yes, sir.
So what's the parabolic equation? What we learn?
So alpha's value given.
Alpha.
Yes, parabolic equation. So what is the parabolic equation? Del u upon del t is equal to alpha.
Del square y upon del square u upon del
It's
x.
not a y, it's a u, no?
Yes, sir. U.
If you compare these two equations, u is equal to T, temperature. And what else? Alpha is equal to
2.
So alpha value is given. Alpha value is given.
2.
Now, what's the use of alpha value here? Can anyone please?
To calculate gamma.
Gamma, right? To calculate the gamma. What else we are having here? Delta x. Delta x is equal to 1 and delta t is equal to 0.24.
0.25.
Now, formula. Tell me which formula we are using here for parabola. To find out the value of u.
U1 is equal to gamma.
Actually, which u we are finding out?
Sorry, U top. U
U
up.
top we are finding out. U up, we say that. U up or V top. It is U left, it is U right, and this is U
U mid.
mid or center. Now tell me formula.
U top is equal to gamma U right plus bracket 1 minus 2 gamma U mid plus gamma right or gamma left.
See, it is U up or you can write U top. Come on. U up is equal to this value. We have to find out. U up is equal to gamma U
right.
left plus 1 minus 2 gamma
U mid
plus gamma into
U right.
U right. This is the formula where gamma is equal to
K alpha upon H square.
K alpha upon H square. Now tell me what's the K and what is the H here?
Sir, K will be 0.25 and H will be
H
1.
will be 1.
Along x-axis, it is h. Along y-axis, it is k. So what is along x-axis? It is the distance. So distance is given by delta x. So h is equal to delta x is equal to 1. And along y-axis, what is there? Time. So along x-axis, y-axis, k is equal to delta t is equal to 0.25. Okay. Hello.
Yes, sir.
Yes, sir.
Yes,
Now
sir.
tell me, what is gamma value? Gamma remains constant. 0.25 into alpha 2 divided by 1 square. Is it 0.5?
Yes, sir.
Yes, sir. 0.5.
0.5. Now next part is very simple. Right? So what we are doing? We are preparing one table. Do you remember the table? How to prepare?
Yes, sir.
We got y-axis, we got x-axis. Along x-axis, we have x distance. Along y-axis, we have
Time.
so x is varying from 0 to 4. What is the step size? What's the value of h?
1.
1.
So 0, 1, 2.
Yes, sir.
Yes, sir.
I was talking about like, so if you are looking at this diagram now, along x-axis there is a distance, along y-axis there is a time. So using same phenomena, we are going to prepare the table. Okay, actually it is a grid system. Let me quickly finish this. I don't think we are in position to continue further because laptop battery is still at the end, no? Okay, along y-axis we got a time. So time varies from 0 to 1.5.
0.25 to
1.5
1.5.
at a rate of 0.25. So what I'll do, we'll write here like 0, 0.25, 0.5, 0.75, 1, and what's the value? Last one?
Sir, two more values.
1.25, 1.5.
2.5 and 1.5.
1.25 and 1.5. So this y-axis grid is like this. So complete that grid. Okay, let it be. Few lines I'll explain because I don't think further it will help us. See, it's a very important the problem statement to understand what's the initial condition. At t is equal to 0, temperature is given. At t is equal to 0, temperature is given again 54 minus x. What does it mean? What does it mean, students? When t is equal to 0, entire values are being given by
The provided equation.
what's that? 54 minus
Into 4 minus x.
x. Okay. And second condition, what is that condition?
So temperature at both ends is 0 degree.
Means when x is equal to 0 and x is equal to 4, the temperature for all the times means for all times is equal to 0. What does it mean? Here at 0, it is 0, 0.
Yes, sir.
Yes, sir.
Okay. We were talking about like in y-axis, it ranges from 0 to 1.5 and with an increment of 0.25. So we have to divide entire range with a step size. Okay, for a t. As we were talking about like, just a minute. is all these values so that we can write the same notations. It's already be calculated. So we will write here. This is U1. This is U1, U2, U3, U4. नोटेशन तुम्ही काही देऊ शकता, काही हे नाहीये, प्रॉब्लेम नाहीये. You just give the notation according to you. 8, U9, U10, U11, U12, U13, U14, U15, U16, U17, U18. Okay, so total 18 values you have to calculate. So how to calculate these values? Yes, friends, how to calculate these values?
Inverted T.
So inverted T you have to use. So how to use that inverted T? So ensure that we have to find out U1, right? Well, U1 find करायचं आहे. एक vertical line काढायची draw आणि त्याला associated म्हणजेच nearby values you have to just find. So this value becomes your mid value. This is left, this is left, this is right. Okay, and this is what you have to find out. So first we'll so this is value we have to find out, that is U1. This value is 100, mid value is 150, and this value is 0. So can you tell me equation for U1?
.5.
Okay, we'll write first what's the U value, no? U up is equal to gamma U left plus 1 minus 2 gamma U mid plus gamma into U right. Tell me. Gamma value काय आपल्याकडे इथे?
0.5.
0.5 into U left 0 plus 1 minus 2 into 0.5 U mid, that is 150 into 150 plus gamma 0.5 into U right 100. That is your U1 value. So simple. Tell me this value. Again, you can use this equation. You can use a calculator to write this equation. Like this value is constant, no? We can write this A, B, and this is C. So you can write this equation in a calculator because we want that equation later on to find out all the values. So what I'll do, 0.5 into alpha A. Alpha A means what? Left value plus 1 minus 2 into 0.5 into alpha B. Alpha B means what? Middle value plus 0.5 into alpha C. C means what? Right one. Just calculate. And if you are calculating, you will get the same value, like only A value you have to substitute. What's the A value? What's the A value? 0. B value 150, middle value. C value is 100. You will get the value 50. So this value is 50. So you can write this 50 here. Okay. Simulate. Now we have to find out U2. Draw a vertical line and find left and right value, and this is going to be your middle value. Second. You have to find out U2. Middle value is known to you, 100. This value is 50. This value is 150. So you can use U2 is equal to. Okay. So use this calculator. So left value is 150. Middle value is 100. Plus right value is 50. You will get this value. U2 is equal to 100. You can write this 100. Okay. Next, draw vertical line, find out the right and left and the middle value. And third, keep on continuing for U3, U4. You can find out all these values. Any doubt? Any question? No? Hello?
No, sir.
No, sir.
Now I think partial differential equation we have done. What's the next? I'll just take you through Gauss elimination. Okay, I have shared already one numerical Gauss elimination. I would like to discuss that only. Gauss elimination with partial differential. And then one request is there for NR methods. Huh? We'll discuss one method. Okay, Thomas algorithm also I shared with you. Just check that. It's a simple elimination, no? Forward elimination method. Tridiagonal matrix algorithm. TDMA, or it is also called as the Thomas algorithm. So in a Thomas algorithm, what you are having, it's a special case first. The equation that you are having a tridiagonal. Tridiagonal, what does it mean? So you can see that tridiagonal. The central main diagonal is there, and associate means are nearby. Two diagonals are there. This is the special case where you can have tridiagonal matrix. So for this tridiagonal matrix, you can solve using Thomas algorithm. Okay. Let us try to understand how we can solve this. I shared document, and with that reference only we'll discuss. Okay, this is the equation. So either you will have in a matrix form or in the equation form. If it is in the matrix form, you have to convert that into equations, right? So our aim is like using equation number 1 and 2, you have to first eliminate x1. So to eliminate, you are going to use 1 and 2 because it has an x1 elements, right? So first upon what we'll do, forward elimination, we'll consider 1 and 2, we'll eliminate x1. Then what equation we are having in terms of x2 and x3? Now, next I'm going to eliminate x2. So to eliminate x2, I'm going to use equation number 3. Okay. So using an equation number 3 and equation number 5, we can eliminate x2. You will get an equation in terms of x3 and x4. That is the equation 6. And using equation number 4 and 6, we can eliminate x3. Then you will get x4. Now, after having an x4, what we'll do, we'll back substitute. Okay. I'll substitute. Back substitute means what? I'm having x4 value here. So I'll substitute in equation number 4. I'll get x3. After having x2 and x3, I'll substitute in equation number 3. Back substitution. I'll get x2. By having x2, x3, x4, I'll substitute in equation number 2. I will get x1. So by having a back substitution, we can get x1, x2, x3, and x4. So simple. Thomas algorithm, right? This is one way. I would like to avoid at this moment a second method. This is the second method, second way to find out. This is the actual method through which we are writing a program. But this is quite simple. So we can use this forward elimination and back substitution method, right? Tridiagonal. And second, what we are going to discuss is Gauss elimination. I shared 2 examples, Gauss elimination practical example. See, this question is again very, very important, students. We can, this is what 3 to 4 times university has asked this question. The upward velocity of a rocket is given at 3 different times in the following table. So time and the velocity is given, right? At time is equal to 5, the velocity is this. At time is equal to 8, this is the velocity. At time is equal to 12, this is the velocity in meter per second. The velocity, relation between velocity and time is given by this equation. Okay. So what is that equation? That equation is also given. Velocity is equal to at square plus at plus a3. Okay. So where a1, a2, a3 are the coefficient constant that we have to find out. Now this is what the given. And they are asking us using Gauss elimination with the partial pivoting, you have to find out the value of A1, A2, A3. So basically, we learned that Gauss elimination can be used for a simultaneous equation. What does it mean by simultaneous equation? If we have three unknowns, three equations, but here they have given only one equation, but that is too incomplete because we don't have a value of t here. So what we will do, at a time is equal to 5, we will write this equation. So at a time is equal to 5 seconds, the velocity is given 106, right? So what I'll do, in this equation, we'll put the value of time is equal to 5. So time A1 time is equal to 5 means 5 square. A2 into 5 plus A3 is equal to 106. So for time is equal to 5, we'll substitute that value, you'll get the first equation. Similarly, when time is equal to 8 seconds, so you can substitute the value of time is 8 in this equation, and the velocity is given 177.2. So you'll get the second equation. At time is equal to 12, you'll get the third equation. So you will get three equations here, simultaneous, three unknown, three equation, A1, A2, A3. When you are using a Gauss elimination with a partial pivoting, first of all, we'll convert that equation into the matrix form. So what is the matrix form? AXB. This is the matrix form. And we are only doing the row operation, not a column operation, because we are doing partial pivoting with row operations, right? So after writing these equations in the form of matrix, we will have a coefficient matrix, variable vector, and the constant column, right? Then we will write augmented matrix. What is the augmented matrix? We are just going to augment coefficient matrix and the constant matrix. So here we are going to, whenever we are performing the operation, we will perform on coefficient matrix as well as the constant matrix. Now, first of all, you have to check whether there is a need of partial pivoting. Partial pivoting means what? We have to find out the first column, first element. This element. That should be a maximum. लक्षात आलं का? पार्शियल पिवटिंग. आता पहिल्या कॉलम मध्ये सगळे एलिमेंट चेक करा. कुठला मॅक्सिमम आहे? 114. So we have to take entire row here as a first row. So what we'll do, we'll exchange here. And the exchange of or switching of a row is called as the partial pivoting. To ensure the first element, first column, first element should be maximum. Okay. तर आपण काय केलं? पार्शियल पिवटिंग. पार्शियल पिवटिंग मध्ये काय केलं? टू एन्श्योर केलं की पहिला कॉलमचा पहिला एलिमेंट जो आहे डायगोनल एलिमेंट तो मॅक्सिमम असला पाहिजे. एकदा तो मॅक्सिमम झाला म्हणजे काय केलं आपण? R1 एक्सचेंज केला R3 शी. बरोबर आहे? एक्सचेंज केल्यानंतर आपल्याला हा पहिला एलिमेंट मॅक्सिमम आला. आता आपण काय करणार आहोत? फॉरवर्ड एलिमिनेशन. सो बाय युजिंग दिस एलिमेंट विल मेक दिस एलिमेंट अँड दिस एलिमेंट 0. त्यासाठी आपण काय केलं? ह्या एलिमेंटला 1 केलं जेणेकरून आपण ह्या दोन्ही एलिमेंटला 0 0 करूया. ठीक आहे. सो विल परफॉर्म रो ऑपरेशन, विल मेक दिस ॲज अ 0 0. जसं आपण रो ऑपरेशन करतो ना स्टुडंट्स, इट इज ऍप्लिकेबल फॉर एंटायर एलिमेंट्स ऑफ दॅट. एकदा हे 0 0 झाल्यानंतर नंतर पुन्हा आपण चेक करणार आहोत की पार्शियल पिवटिंगची गरज आहे का इथे. सो सेकंड कॉलम, सेकंड एलिमेंट शुड बी मॅक्सिमम. डायगोनल एलिमेंट्स, हा कॉलम काय पाहिजे, हा एलिमेंट काय पाहिजे, मॅक्सिमम. सो इफ यू आर कंपेअरिंग सेकंड कॉलम, हा आता पहिल्या रोला डिस्टर्ब नाही करायचं. पहिला रो ऑलरेडी डन हिज जॉब. आपण फक्त या दोन कॉलम मध्ये, दोन रो मध्ये कम्पेअर करणार आहोत की कुठला एलिमेंट मॅक्सिमम आहे. तर यामध्ये तुम्हाला लक्षात येऊन जाईल की हा एलिमेंट मॅक्सिमम नाहीये. सो व्हॉट विल डू, विल एक्सचेंज दी rows, ensuring that this element is a maximum. मग आपण काय केलं? पार्शियल पिवटिंग केलं. We switch or exchange the row R2 R3 जेणेकरून हा एलिमेंट काय आला? मॅक्सिमम आला. मग ह्याला आपण काय केलं? ह्याचा यूज करून त्या एलिमेंटला 0 केलं. ठीक आहे, इथे 0 केलं. एकदा हे अप्पर ट्रायंग्युलर मॅट्रिक्स मध्ये फॉर्म मध्ये आला नंतर आपण काय करणार आहोत? वी आर जस्ट युझिंग मॅट्रिक्स फॉर्म. सो वी विल राईट लाईक, आणि हे मॅट्रिक्स फॉर्म लिहिल्यानंतर आपल्याला काय मिळेल? अ सेट ऑफ इक्वेशन्स. देन वी आर गोइंग फॉर बॅक सबस्टिट्यूशन. सो फॉर युझिंग बॅक सबस्टिट्यूशन विल गेट द A3 फर्स्ट, A2 and A1. All these values are nothing but your Gauss elimination with partial pivoting. So also important here, the partial pivoting. Partial pivoting कधी कधी करतो एक लक्षात घ्या. दोनच वेळेला 3x3 मॅट्रिक्स साठी दोनच वेळा आपण पार्शियल पिवटिंग करतो. पहिला कुठला? पहिला कॉलम कम्पेअर करायचा पहिल्या कॉलम मध्ये बघायचं, पहिला इलेमेंट जो डायगोनल एलिमेंट आहेत ना, त्यातला पहिला इलेमेंट, पहिल्या कॉलमचा पहिला इलेमेंट जो काय पाहिजे, मॅक्सिमम पाहिजे. तो एक जर मॅक्सिमम केल्यानंतर हे दोन इलेमेंटला त्याच्या खालचे जे दोन इलेमेंट्स आहेत त्याला झिरो करायचे. इथे झिरो केले. एकदा ते झिरो झाले तर आपल्याला फक्त दोनच इलेमेंट्स आहेत. दोन रो मध्ये सेकंड कॉलमचा इलेमेंट कम्पेअर करायचा डायगोनल. सॉरी. मग इथे लक्षात येऊन जातं की हा इलेमेंट मोड, हा आता काही जणांचा असा क्वेश्चन आहे, जर इथं मायनस असतं तर काय केलं असतं, तर मॉड घ्यायचं. ज्यावेळेस तुम्ही कम्पेअर करताना मॅक्सिमम व्हॅल्यू, इट शुड बी द ऍब्सोल्यूट व्हॅल्यू. जरी इथं निगेटिव्ह व्हॅल्यू असती तरी मी काय केलं असतं, मॉड घेतलं असतं. तर मॉडची व्हॅल्यू कम्पेअर केली तर मला लक्षात येतं की हा व्हॅल्यू काय मॅक्सिमम आहे. तर आपण काय करणार, ह्या दोन एक्सचेंज करणार रोज. एक्सचेंज केल्यानंतर ही मॅक्सिमम झाली. जस्ट तुम्ही एक्सचेंज करताना रोज टू एन्श्योर दॅट दी diagonal element is maximum, and that method is called as the partial exchange. हे मॅक्सिमम करण्यासाठी. हे एकदा मॅक्सिमम झालं तर ह्याचा यूज करून काय करणार, त्याला आपण झिरो करणार. इथे बघा झिरो केलं. आणि एकदा हे तीन इलिमेंट झिरो झाले तर त्याला काय म्हणतो आपण, अप्पर ट्रायंग्युलर मॅट्रिक्स. आणि नंतर आपण यूज करून काय करतो, बॅक सबस्टिट्यूशन यू विल फाइंड आउट A3, A2, A1 व्हॅल्यूज. एनी क्वेश्चन स्टुडंट्स?
हॅलो सर. सर पार्शियल पिवटिंग आपण जेव्हा करतो तेव्हा क्वेश्चन मध्ये दिलेलं आहे ना, गॉस सॉल्व गॉस इलिमिनेशन विथ पार्शियल पिवटिंग.
जरी दिलं नसेल तरी शक्यतो बाय डिफॉल्ट यू हॅव टू यूज अ पार्शियल पिवटिंग.
ओके सर.
Partial pivoting is only one method, like to avoid truncation errors, round of errors, and the error that is caused by zero division. याच्यासाठी आपण पार्शियल पिवटिंग करतो. पार्शियल पिवटिंग खूप सोपं आहे. फक्त आपल्याला काय करायचं, दोन इलिमेंट मॅक्सिमम आहेत का एवढंच चेक करायचं. अदरवाइज वी आर फॉलोइंग द गॉस एलिमिनेशन मेथड्स ओनली. गॉस एलिमिनेशनचा मेथड काय आहे सांगतो तुम्हाला. हा पहिल्या रोचा सॉरी पहिल्या कॉलमचा पहिला एलिमेंट यूज करून त्याच्या खालचे दोन इलिमेंट्स काय करायचे, झिरो करायचे. पण पार्शियल पिवटिंग काय सांगतं की हा एलिमेंट मॅक्सिमम आहे का पहिल्या कॉलम मध्ये, नाहीये, तर मग ह्याला मॅक्सिमम करा पहिला. मग मॅक्सिमम कसं करू शकतो, ह्या कॉलम मध्ये बघायचं आपला कुठला एलिमेंट मॅक्सिमम आहे, 144 मॅक्सिमम. मग हे दोन रोज काय करायचं, एक्सचेंज करायचे. एक्सचेंज केल्यानंतर पूर्ण रोज, प्लीज लक्षात घ्या, हा पूर्णच्या पूर्ण रो आहे ना, इथं रिप्लेस केलेला आहे. येते लक्षात. यावेळेस आपण एक्सचेंज करतो किंवा रो स्विच करतो, त्याला काय म्हणतात बेसिकली पार्शियल पिवटिंग. आणि पार्शियल पिवटिंग का करायचं, तर हा एलिमेंट मॅक्सिमम आला पाहिजे. हा एकदा मॅक्सिमम आला तर याचा यूज करून काय करायचं, या दोघांना झिरो करायचं है ना. हे एकदा झिरो झाले तर मग आपल्याला काय राहतो, फक्त एक एलिमेंट झिरो करायचा राहतो. ठीक आहे ना. आपण इथे लक्ष झालं बघा, ह्याचा यूज करून सेकंड कॉलम सेकंड एलिमेंट यूज करून काय करणार होतो आपण, त्याच्या खालचा एलिमेंट झिरो करायचे, जेणेकरून आपल्याला अप्पर ट्रायंग्युलर मॅट्रिक्स फॉर्म झाला पाहिजे. अलग लक्षात.
येस.
3x3 मॅट्रिक्स साठी दोन वेळा पार्शियल पिवटिंगची गरज पडते. ठीक आहे. हे पार्शियल पिवटिंग झालं. दुसरं काय आपल्याकडे आता,